Welcome back to Maths with Mrs. J. This is going to be our final video in our videos about solving equations, for now anyway. I wanted to just put together what we've learnt so far about solving our quadratic equations, because we have learnt several different methods there. Let me just sort of bring it back to the basics. Unless you are told to use a particular method, if you can factorise the quadratic, do, okay? And then use your null factor law. If you can't factorise it, either if you can't just factorise it, you're having a bit of a mental blank and you can't do it, or if it literally cannot be factorised, if it's already part way towards completing the square, go that way. Otherwise, use your quadratic formula. If your discriminant comes out to be negative, then there will not be any real solutions. So it's okay to show that the discriminant is negative and say no real solutions. All right, let's have a look at this first one here. X squared minus 5x plus 6 is 0. All right, we've got a 1 in front of our x squared. Can we find two numbers that multiply to give positive 6 and add to give negative 5? Yes, we can. X minus 2, x minus 3 equals 0. That was fairly easy to factorise. So your null factor law is going to tell us that either x minus 2 is 0 or x minus 3 is 0. So x is 2 or 3. That one was nice and simple. Let's have a look at this next one. Now, notice that we have a 3 in front of our x squared, but also notice that the other terms are both divisible by 3. Because it's an equation, I would be inclined to just divide the whole lot through by 3 before doing anything else. Don't bother even trying anything else until you've got it in the simplest possible form, which you can do because every single term is divisible by 3. Once you've done that, this one's actually quite a nice easy one as well. If you have x plus 4, x minus 1, that fits the bill of multiplying to give negative 4 and adding to give 3. So x is either negative 4 or positive 1. So that one's quite a nice one as well, which is kind of handy. Let's go through and try a few more. Okay, let's have a look at this next one. Well, this next one has a coefficient other than 1 of our x squared term, but the other terms are not all divisible by 3. So we can't just divide the whole thing through by 3. Well, we bring in fractions and we don't particularly want to do that. Let's have a think about, this is a quadratic expression where we've got a as 3, b as 9, and c as negative 5. Can we think of two numbers that multiply to give ac, so they multiply to give negative 15, and they add to give 9? Not looking terribly likely, is it? Let's work out what b squared minus 4ac is, just to give us a little bit more info. So b squared will be 9 squared minus 4 by 3 by negative 5. So that's 81 plus 60, which is 141. Okay, so that's why it wasn't possible to split up that middle term the way we normally would if we were going to factorise. Because the discriminant is positive, there will be two solutions, but they're not going to be rational solutions. 141 is almost 144, but it's not. So it's not a perfect square. So let's go ahead and use our quadratic formula, and we've already done the hard part there. You can even do that if you like. Subbing in, so we get negative 9 plus or minus square root 141 over 6. And I'd be inclined to just leave it like that. 141 doesn't have any perfect square factors, so I'd just leave my two answers like that. If you wanted an approximation, then you could, on your calculator, do negative 9 plus root 141 and divide that by 6, and negative 9 minus root 141 and divide that by 6. Square root of 141 would be nearly 12, wouldn't it? Because the square root of 144 is 12. All right, last one. Let's see, can we think of two numbers that multiply to give 30, which is our AC? So A is 3, B is 9, C is 10. So AC is 30 and our B is 9. Can we think of two numbers that multiply to give 30 and add to give 9? Let's think about it. Not so sure? What are our factors of 30? We've got 30 and 1, we've got 15 and 2, we've got 6 and 5. Not going to work, is it? So let's do our B squared minus 4AC, which is going to be 9 squared minus 4 times 3 times 10, which is 81 minus 120. Aha, that's why we couldn't factorise it. We have a negative discriminant. So not only are we not going to get rational solutions, we're not even going to get real solutions. So this cannot be solved in the real number system. So no real solutions, and it's perfectly fine to leave it at that.